All right, welcome back. This is the part two of our microservices deployment on AKS demo. And in this particular video, we would be going into all these steps to make this solution work. I hope you would like it. With that, let's get into the lab. Obviously, first step is to create the Azure Container Registry and Azure Kubernetes Services AKS cluster, three nodes that we have seen in the diagram. This is where we would deploy all the required microservices component. So it's very straightforward. I have defined certain variables here, right? If you see here, the resource group name, the name of the registry, the location, and name of the AKS cluster. We run the command AGACR create. We log in there, making sure we then create an SPN here in this command. We would note the app ID and password. Many of you who have done it in past are very familiar with this. Then we go and get the string for the ACR, right? So resource group name and then the name of the ACR. We query the ID. Once we get the ID, we copy that string. We do the RBAC here. We assign the role, right? We define the scope that we copied in the string. We define the app ID that we got it here, and then we just run the role-based access control and followed by creating the whole three node cluster, right? So straightforward. Let's execute these steps in the lab. So we have finally completed all the steps. Our three node AKS cluster is created. If you see here, this is just finished here. We can look into the portal and see that all the components are added here. So if I go back here and we look into our resource group here, and our resource group that we used for creating that was Microservices AKS. We have our AKS cluster, we have got our registry, all the required infrastructure for this AKS cluster should have been created into this one, MCN and microservices. And let's look into that. Right, so we have everything right from NSGs, route table, virtual machines, this IP network interface, everything is ready from the cluster perspective. We can start and working on our next few commands. So the next phase is to create or rather pull the required images to Azure Container Registry directly from the GitHub, right? And it's a straightforward process. We're not using intermediate Docker desktop here. If you want to try and test locally, you might want to do that. But for this lab, we are bypassing that and we are directly downloading the images from GitHub to the Azure Container Registry. In your real production environment, you may follow your own processes here from DevOps perspective, but in this lab, we will just pull it, right? But before we do all the, before we pull those images, we just need to make sure that our cluster is healthy. So we would run a few commands. I'll show you in my lab. Then we would also configure Kubernetes to use ACR. We will basically get the ACR password that we would use to create a secret, and that secret would be used for further configuration down the road in the lab, right? The commands are here. Then we will build the container image with the ACR. This is the topic here. We have to build two separate images, one for the data API image. If you remember the first visual that I showed you, the data API image was at the bottom, which is going to talk to the MongoDB stateless container there, stateless part there, and then we will also create a stateless front-end app. We'll download it from GitHub. Once we are done with that, we'll check the ACR content that all our images are showing up, and that is the end of this third phase here, right? So let's look into the lab. And if you go into the lab right away, let me pause it here to pull it all the way up. So after we completed the cluster creation, the 3-node cluster creation, we went into the AKS get credential command as per the slide. We merged our context here, right, successfully the user here. Then we look into our nodes. As you know, we created the 3-node cluster. They are up and running. They are ready. They're running for 13 minutes here, 14 minutes here. Their version is here. Then we looked into the cluster information to making sure that everything is good. Our Kubernetes master is running, our Hepster is running, Core DNS is running, Kubernetes dashboard is running, and our metric service is running. So it looks good to me. Then we go and look into the all Kubernetes systems here. We see everything good here. No issues, external IPs, services, namespaces. Everything looks good here, right? Then we went into creating the ACR password command that I showed you in the slide. It's right here. I also checked the ACR password here, right here. And then I tried to create the secret auth here. I made a mistake here because I didn't put the right variable here for ACR, and that's why I errored out here. And then in following command, I think I fixed it. So when I ran the command next time, I had the right variable here, and I got the ACR secret, the secret created properly, which is ACR auth, that we're going to use it. Then we started downloading the images from GitHub. First image that we downloaded is for the data API, which is going to talk to the MongoDB, and it goes into its process of downloading and configuring and pushing that images, right? So this is all took some time here. And after that, we downloaded the front-end web app API here, and that step is also covered. We then checked the contents here, and we have both the images in our ACR. So that concludes the third phase, and now we'll move to the fourth phase. The next step is to create all the required microservices, and as we know and we have been seeing it, that we would need to create 3 different microservices in our solution. One would be the front-end web app, and the second would be the data API, third would be the MongoDB. We will start with creating a MongoDB. We'll create a mongo.deploy.yaml file. I'll show you in a second. And once we do that, then we will create run that apply file. Basically, we are deploying that that image that we have created into the AKR cluster, and it would create the required pod and required container. We'll check that everything is good. Similarly, we will create the data API, and I'll show you in a second. So if you go into my notepad here, this is the example of the Mongo deploy YAML file, right? So we are defining it as a service. This is the API version. We are giving the metadata MongoDB. We are creating only a single replica here, right? We are putting a label here that we would be using down the road. App name is MongoDB, and it would pull the image from GitHub. This image Mongo 3.4.json, and it is going to expose port 27017 inside the pod to the cluster, right? That's very straightforward. Similarly, we have created in deployment for the data API, and again deployment app services name. We are creating only one replica. Name is data API. We are tagging it here, right? And container port that we are using here is 4000 to the cluster. This is our value that we will change down the road. Okay, and as we mentioned here, that we would be using that secret that we created earlier. Here is what the secret we are going to be using here. I don't know whether we are using secret here. Yep, we are only using secret here in the data API, right? And then we are ready to execute these commands. So we applied the file kubectl applied mongo.deploy.yaml. We got a good message. Well, MongoDB is created. We checked it and it's good already. So the MongoDB is now running, and now we can create the data API here, right? So we probably would follow the same step here and just start doing that. I forgot to mention that we also need to run this command here. Basically why we are doing it is to get the IP address of this MongoDB pod, which is here. We need to copy this because down the road we will be using this IP initially, which is a bad practice. We'll talk about it, to connect the data API to the Mongo database, right? So basically you remember that MongoDB is the stateful, so we need that IP to allow the data API connection, data API pod connection to the MongoDB pod, right? So that's the reason we need to run this command, and we have successfully completed that. And now we can continue working on. So basically, I apologize, I forgot one step here, and that would not let us connect the data API to the MongoDB. First thing that I forgot to mention here, that in this one you need to make sure that you use your ACR registry login server name, right? So this is what you need to modify it in your environment. That's number one. And number two is that IP that we got for the MongoDB part in the earlier command that we ran, we need to replace here for allowing the data API to connect to this MongoDB. And that value was not updated here earlier in my file. So now we have updated it, and we can reapply this file and make sure that the data API is now connecting to the Mongo database, right? So that's our next step. So I reapplied the file here, guys, right? Fixing the IP address of the MongoDB. And once I did that, I ran the command to make sure that my data API is now connecting to the Mongo database. Good news, this is good, it's in production and connected to attempt to the MongoDB instance and 10.244.1.2, which is the IP that we got earlier. Yay, we are connected to the MongoDB and API is listening on 4000. So that step is now complete, and we are ready to move forward into the next step. So now we're gonna access the data API, and in order to do that, first of all, we need to know the API pod name for the data API. Once we would run the command kubectl get pods, it will give us the pod being used by the data API. We capture that, and then we will set the port forwarding tunnel from the local host, which is running on port 8080 to the port 4000 actually. My mistake. And we have to run it from another console. Once we run this command, we will replace this data API pod name with the actual API pod name that we get out of the get pod command, and then we will see that the data API is running or not, right? We'll be running it back from the original console. So folks, this curl command was giving me errors here, and that's what I decided to change the command and use this command. And that gave me the details that is up and running, right? It's good here, so we can continue doing that. This is all good here, and now we can move to the next step. The next step is to create all the required microservices, and as we know and we have been seeing it, that we would need to create 3 different microservices in our solution. One would be the front-end web app, and the second would be the data API, third would be the MongoDB. We will start with creating a MongoDB. We'll create a mongo.deploy the YAML file. I'll show you in a second. And once we do that, then we will create run that apply file. Basically, we are deploying that that image that we have created into the AKS cluster, and it would create the required pod and required container. We'll check that everything is good. Similarly, we'll create the data API, and I'll show you in a second. So if you go into my notepad here, this is the example of the Mongo deploy YAML file, right? So we are defining it as a service. This is the API version. We are giving the metadata MongoDB. We're creating only a single replica here, right? We are putting a label here that we would be using down the road. App name is MongoDB, and it would pull the image from GitHub. This image Mongo 3.4.json, and it is going to expose port 27017 inside the pod to the cluster, right? That's very straightforward. Similarly, we have created in deployment for the data API, and again deployment app services name. We are creating only one replica. Name is data API. We are tagging it here, right? And container port that we are using here is 4000 to the cluster. This is our value that we will change down the road. Okay, and as we mentioned here that we would be using that secret that we created earlier. Here is what the secret we are going to be using here. I don't know whether we are using secret here. Yep, we are only using secret here in the data API, right? And then we are ready to execute these commands. So we applied the file kubectl applied mongo.deploy.yaml. We got a good message. MongoDB is created. We checked it and it's good already. So the MongoDB is now running, and now we can create the data API here, right? So we probably would follow the same step here and just start doing that. I forgot to mention that we also need to run this command here. Basically, why we are doing it is to get the IP address of this MongoDB pod, which is here. We need to copy this because down the road we will be using this IP initially, which is a bad practice. We'll talk about it, to connect the data API to the Mongo database, right? So basically, you remember that MongoDB is the stateful, so we need that IP to allow the data API connection, data API pod connection to the MongoDB pod, right? So that's the reason we need to run this command, and we have successfully completed that. And now we can continue working on. So basically, I apologize, I forgot one step here, and that would not let us connect the data API to the MongoDB. First thing that I forgot to mention here, that in this one you need to make sure that you use your ACR registry login server name, right? So this is what you need to modify it in your environment. That's number one. And number two is that IP that we got for the MongoDB part in the earlier command that we ran, we need to replace here for allowing the data API to connect to this MongoDB. And that value was not updated here earlier in my file. So now we have updated it, and we can reapply this file and make sure that the data API is now connecting to the Mongo database, right? So that's our next step. So I reapplied the file here, guys, right? Fixing the IP address of the MongoDB. And once I did that, I ran the command to make sure that my data API is now connecting to the Mongo database. Good news, this is good, it's in production and connected to attempt to the MongoDB instance and 10.244.1.2, which is the IP that we got earlier. Yay, we are connected to the MongoDB and API is listening on 4000. So that step is now complete, and we are ready to move forward into the next step. So now we're gonna access the data API, and in order to do that, first of all, we need to know the API pod name for the data API. Once we would run the command kubectl get pods, it will give us the pod being used by the data API. We capture that, and then we will set the port forwarding tunnel from the local host, which is running on port 8080 to the port 4000 actually, my mistake. And we have to run it from another console. Once we run this command, we will replace this data API pod name with the actual API pod name that we get out of the get pod command, and then we will see that the data API is running or not, right? We'll be running it back from the original console. So folks, this curl command was giving me errors here, and that's what I decided to change the command and use this command, and that gave me the details that it's up and running, right? It's good here. So we can continue doing that. This is all good here, and now we can move to the next step. Alright, so the next step is to create the Kubernetes services, and the big question is that why do we even need to do that, right? So in our last step, if you recall, what we did here is a couple of things, that we have used the MongoDB IP to allow the data API to connect to the MongoDB IP. And we also did the port forwarding. Both of them are a real bad practice, right? This is not a good idea to do it because of several reasons, right? And one of the reason is that in Kubernetes, IP addresses and pod names are never fixed, because you know that they both are ephemeral and mortal. They should be considered effectively transient. So it's a bad idea to use IP, because you never know when that pod would be destroyed and the new pod would be created. Here are the additional reasons. When scaling deployments to multiple replicas, how can we know that IP address is the name of the pod, as there will be many, right? You see that when we are scaling it, that's what the big situation pops up, and that's why it's gonna solution is just gonna ruin us. Pods can move, be rescheduled between nodes due to failure, resource scheduling, or other reason. This will result in the pod being destroyed and recreated. That's what I mentioned earlier, on a different machine, and it is likely the IP addresses will change. So again, that's a very bad idea. Rolling updates when applying a change, when we are updating the cluster image, right, or running a deployment, employs a rolling update strategy. This is also results into being destroyed and recreated, right? Because as you know, the containers are immutable. You can't write on them. So as a result, whenever you try to make a change, they are destroyed and recreated. And in that scenario, the IPs are going to change, and the forwarding is automatically going to get messed up. So what's the answer? What's the solution? The solution is to create the Kubernetes services, right? And when we create, in this scenario, we'll create a MongoDB services, we'll create a Mongo services YAML file that I'll show you. We'll apply that, and we'll see that the service is up and running. This service would have the built-in IP, and it also uses the built-in Kubernetes DNS, which is out of the discussion here, but it automatically does all the tasks behind it. So you don't need to go into the complexity of DNS to understand that, but that DNS part is being done within the Kubernetes orchestration role. That takes care of it, and the IP is embedded into that. And once we have that service, so what we're going to do is that the data API that we deployed earlier, we're going to change the file. We're going to change the file and change the IP that we used earlier to the service, right? That's what we just talked about. That's a bad idea. Now we have the service that is the service has an embedded IPs inside it, so we don't need to worry about IPs anymore. And that is the preferred way. That's the right way to do that. We will apply that API file back, YAML file back again, so that we can make the changes for the data API pod to be able to talk to MongoDB, not on IP address but on a service. This is a major important area to understand. Once we do that, we are good. We'll make sure we'll check it that everything is up and running. Basically, when we are doing that, we are making sure that by making a change from IP to this name, is our data API is still connected to the MongoDB or not. That's what this particular command would do that for us, right? Apologies. Just a second. Right. And then we also would create similarly the same thing we will do for the data API services. And we will create a data API services YAML file, we'll apply, and we'll watch the service. Now there is difference between these two services which we're going to see in the YAML file. Once we would initiate this service, this would create an external IP, a load balancer IP, which takes few minutes to show up, sometime 5 to 10 minutes. We need to watch this, and we need to note this IP, because we will be using it with the front end web app there. We would allow the front end web app to be able to talk to the data API through this IP address, right? So that's the next step. So that's very important, right? So let's look into the Mongo SVC file or YAML file here, which is what is a service file that we are creating, right? So we go back into our notepad and we go into the Mongo service YAML file. So it's very straightforward, right? But the important part here, when we create services, we can create services in multiple ways. In this solution, we can create services type cluster IP or a load balancer IP. The cluster IP is an internal IP, right? It's not exposed, not a public IP. But because when we go to that data API here, you will see that we are using the load balancer, right, type here. The reason being that this web app is to be publicly accessible, it needs a public IP address. And what would happen with this, that this would have an external, this would create a external load balancer, and the load balancer would get a public IP address that would be configured with all the load balancing rules and backend pool and front end pool as a load balancer, so that the external users can hit and get to this web app, right? That's the whole purpose of this load balancer here, right? There are some challenges that we're going to deal with it because of the security issue, that we would put some web access firewall and other stuff around it. But that's the whole purpose of these two uh, these two YAML files. So you understand this. We have a service file, YAML file, to create a MongoDB service. We have another service file to create the data API service. And then also, let's not forget that we also need to modify the data API, because the data API pod that is running, we configured that with the IP address in past. Now we need to change that IP here with the actual service name that we just created, right? So that's important, and that's what we did with these three files. When we go back here, we execute these commands. So basically, going back here, so the first thing that we did here is that we applied that service file that we created for MongoDB here, right? And it created the MongoDB service. If you see here, when we looked and look for the services and we check the services, now we see the MongoDB service is running here and the cluster IP, and there is no external IP. Remember that in this particular service, we decided to use the cluster IP, not the load balancer IP. That's why you will never get an external IP here. We applied that data API because we modified now the data API. We changed the IP address that we had in past with the new service entry that we created for the MongoDB, following the best practices, following the right solution, and that's what we configured. And then when we check it back again, well, after we modified that pod, the data API pod, now to talk to MongoDB, not on IP but on a service, now we want to check whether that is still connecting or not, right? And we see that the connection attempt to the MongoDB, hey, yay, connected to MongoDB, and that's what we wanted to see, right? That after making this change, we are still able to talk back to MongoDB, which is what the whole purpose of this particular phase was, right? Now, after that, we also created the data API services, but remember here we decided to create a load balancer IP. We created the load balancer IP, and here is what you see. When you start looking for services, you would see the external IP address is being is still pending, right? Now let's do that, and I probably messed up with the command with the watch here. Now if we go down here, now this is what is still pending here, right? Data API. Oh, basically it already got it here, right? So if you see there, data API services, we got the external IP address. So let's do this again. Control C. And here you see, this is our IP address that we need to note down, because now when we configure the front-end web app, we would configure the front-end web app to talk to this IP address, and this is what is our down the road, our story that we need to change and define our security around it, right? So let's pick it up here. Let's just note it down here for future, right? And that completes this particular phase. And now we can move into the next phase. So this is one of the last step. I think there's one more step to dump the data, sample data, but I think we are almost towards the end of this lab. So what we are going to do here, we are going to deploy the front-end service. Again, we are going to create a front-end SVC YAML file that I'm going to show you, and we'll apply that YAML file. That get service would start, and because this would again be using the load balancer type, this is an external facing interface because this is a front-end web app. That's why you will use the load balancer type, and that's where it will get an external public IP address, which is where we're going to watch. And once we get that IP, we'll create another file called as a front-end deploy.yaml file, and we would have to modify that file to make sure that we have the right ACR login server name, and we also have the same right IP address that we captured in earlier step. We will run the cat pods, and then we are pretty much ready from the solution perspective, right? Then we'll go talk about other security initiative that we have designed here, right? So let's see if we can run all these commands here, and let's get into the PowerShell here. So what I did here is, hold on 1 second, this audio messes up. So let's look at the front-end SVC YAML file to create the front-end service. Very straightforward. Remember that we are using the type as load balancer because this is an external facing web app, and that TCP AT internal port that it is going to proxy to is 3000 and front end, right? So that's very straightforward. And now we look into the deploy file, and what we did in the deploy file is deployment replicas is only one. Front end, here we changed the image name. That was to make sure that we have the ACR login server here, and then we changed the IP. That IP we got it after running this service, right? So we'll show you how we did that. So let's look into the lab. And what did we did first, we applied the front-end services YAML file that created the service. Then we watched for the service, right? And then we got the IP here, that is this one. And then we configure that IP. We got that IP here for front-end services, right? So now we have the two public IP on the load balancer, one for front-end services, one for data API services, because this is an Angular application. The user would connect to the web API, the web app. Web app would send it back to the user, and the user would then connect to the data API to get data from the MongoDB, right? That's the microservices architecture here. So we have got both the IPs here, for data IP and the front end a public IP. We don't need MongoDB is an internal stateful there. That's why we don't need a public IP here. We need public IP for both of them, right? And that's what we are good to go. And then we deployed the final file of front-end deployed YAML that we created, and we saw the pod. Everything is healthy. We always configured a single replica. That's why we have a single pod. If we would have created more than one replica, then we should be seeing more than one pod. Now, if we really want, we can start going and looking into this IP, which is for the front-end IP. And if we hit it, we should be able to get to that application, right? So now that's our next phase, to check it and also to dump some data, sample data into the solution, right? So let's pause it here and then dump. So guys, if you look into, I just use that IP here and I am into that application. Of course, there is no data here, right? If I see here reports, there should be no data because we have not pushed any data. Next step is to push the data here, right? So I'm gonna go back here and push. So folks, I ran the command to get the pods for the API data. I got the pod name here, which I use in my next command, right? Data API. Basically, what I'm doing is I'm actually logging on into that pod as a kind of a inside the pod. Now I am in the bash command here. I change the directory and I push the demo data, and you will see here that it created to MongoDB and it has created the event. So if I go back, right, so if I go back and refresh it now, I should see some data. See here now the data is here. Okay, so this brings an end to this presentation. Before I say goodbye to you guys, I also want to mention one more thing. Though in this particular presentation, we have decided to use Akamai as our web access firewall solution, but in your environment, you might choose any solution of your choice. I would also recommend to consider Azure Application Gateway with Web Access Firewall component, features there. That may be an interesting solution too. And as we have already covered the security part of the solution, which was around two things, which was around Akamai and SAP API management. I don't think we need to go again into that. So this concludes our presentation here. Thank you very, very much for watching. I know this is a long video, and if you have watched this long video, I hope that this was worth watching. And if you think that this was good, so please share with your colleagues. Uh, Please also watch my other videos on my channel. And with that, I will say goodbye and have a very blessed day.